Good morning to everyone. This is Sultan, Assistant Professor, Department of Aerospace Engineering, Sanjay University, Kolhapur. In this lecture, we are going to see about that avionics engineering. So, in that avionics engineering, what is that the avionics system requirements? So avionics system design. First of all, how we will be designed the avionics system and where we will be able to place the avionics system. So the starting point of the design a digital avionics system is clear understanding that the mission requirement and the requirement level by the host aircraft. For example, if you are going to design one of the aircraft, so what type of aircraft it is and what are the systems it should be implemented in that the aircraft and what are the advanced system we'll be able to use like that we have to first point out for the design and top level requirement for the military aircraft. So when you're going to the military aircraft, you have to top level requirement you have to fix it in the military aircraft for advanced nowadays. So the customer prepared the statement of need and the top level description of possible mission. For example, I am the person, I'm going to buy one of that aircraft. So I first of all I want to know what are the mission requirements in my aircraft it should be there. So after that mission requirement should be given to the manufacturer. That manufacturer will be prepared that the design and describe the gross characteristics of a hypothetical aircraft that could fly at the mission. Customer may also describe the mission environment and design strategic and tactical philosophies and principle and rules of the engagement. For example, the top level requirement means for the successor to the A-train aircraft. It is one of the example. First one is the takeoff and landing distance. So our goal minimum 3,000 feet it will be required to take off and landing, but we will be achieving 2,000 feet itself. That 1,000 feet, the fuel will be reduced. That is our goal. And turn rate. So in Mach number 0.7 to 0.9, when the aircraft is flying, that turn rate should be taken 10 to 20 degrees per second. And mission radius at low altitude. When the aircraft is flying at low altitude, the mission turn radius should be 250 nautical miles and the mission loiter time 30 minutes is our designing, but the aircraft will be loiter 45 minutes. That 15 minutes should be our additional and turn around time 25 minutes. It's our turn around time, but our goal we are achieved is the 15 minutes. And percentage of all repairs that can be completed within 2 hours. That means if the aircraft is flying 2 hours, I'm sorry, that aircraft maintenance will be taken, 60 percentage of work will be maintained, repairs will be happen in 2 hours means our goal should be as a 65 minutes of the flight time. And then 40 4 hours means 75 is our minimum design and it will be taken 80 minutes. So for 80 hours, it should be as a 85 percentage means if that 95 percentage of that work should be done within the 8 hours. Preliminary thoughts on design. So design is in a general. What is meant by that design? It is a team about large system integration activity done in three stages. One is interactivity, creativity, and the knowledge based. The three stages of the designs are conceptual design, preliminary design, and detailed design. So a system developed cycle. How will be a system will be developed? This is the example of standard 2167 EH system. So first one is the program head. In the program head, system requirement should be analyzed and then system requirement review. That means system design and system design review SDR. So in that system design review SDR, and then preliminary design review PDR, and then critical design review CDR. There should be as a hardware as well as software. So if you are taken that the hardware, requirement analysis, preliminary design, detailed design, after that only it go into the fabrication. For software, requirement analysis, preliminary design, detailed design, and then coding and then unit test. Aircraft mission requirements to the avionics system requirements. So if you have taken that the mission segment requirements, after that only avionics requirements. This will be category as top-down design as well as traceable requirement. These are called as a traceable requirements. So in mission, air supplementary, ground support, passenger transport. This is our mission. So mission segment, taxi, takeoff, cruise, descent, and landing. So segment requirement, roll rate, navigation precision, and map hold. Avionic requirements are head accuracy, weight, reliability. So conceptual design. So in conceptual design, what will it do? What we are going to do and how it will be doing? How we are going to do that and what is the general arrangement of the parts. So all the parts we are manufacture. So how we are going to arrange that? The end result of conceptual design is an artist or an engineer conception of vehicle and a product. Example, clay model of the automobile. This is an example. So for our aircraft, so the conceptual design should be a prototype models. So these are the conceptual designs of the military aircraft and the preliminary design. How big will it be? How much will it weigh? And then what engines will it use? How much fuel or propellant will it use? How much will it cost? This is what will you do in this course. Detailed design. So in the detailed design, how many parts will it have? What shape will they be? What materials you are going to use? How will it be made? How will be the part be joined? How will technology advancement, example lightweight material, advanced airfoils, improved engines, etc., impact the designs? So this is the detailed design of that every component. So whenever going to design one component, that component should be design, preliminary design, and then conceptual design, preliminary design, and then detailed design. In detailed design, we have to definitely analyze through that the software. So whether that the structural members will be withstand the load, or either we have to improve that the component of that the material like that. We have to the detailed design in our aircraft. So this is the example of that A380 arrangements. So specification and standards. The designers need to satisfy customer who will be buy and operate the vehicle. Example Delta TWA, government regulators, US military, European, Japanese. So the designer definitely have to satisfy the customer requirements as well as the government regulations. Customer specification. What are the customer specification? Performance, payload, weight and volume, how far and how fast it will be carried, how long and what altitude it will be flight, and passenger comfort, and flight instruments, ground and flight handling qualities, and the cost, price of system, and staff, useful life, maintenance, hours per flight hour, and government standards. For civil aircraft, FAA FAA Civil Aviation Regulation defines such things as required strength, acoustic, effluent reliability, takeoff and landing performance, emergency aggressive times. For military aircraft, may play a dual role as a customer and a regulator. Military specifications and may set minimum standards for mission turnaround time, strength, stability, and speed, altitude, maneuver capability, etc. So, system integration. So, aircraft or spacecraft design often involves integrating parts, large and small, maybe other vendors into an airframe or space frame, also called the bus. Means if you are taking that the aircraft, there are large number of components are there. That components should not be manufactured by a single company. That should be given to the other vendors. Parts include engines, landing gear, shock absorbers, wheels, brakes, tires. If you are taking that the avionics systems, radios, antennae, flight control, computers, cockpit instruments, actuators that move control surface, retract and landing gears, etc. So this is the year 380 production. So the production companies are there, Hamburg and then Broughton and then Sid Nazare and Stade and Sid Nazare and Getafe and Toulouse, France. These are the companies, all the various components will be made differently. And aerospace design involves lot of analysis, ground testing and simulation. Example, wind tunnel test of model aircraft, flight simulation, drop test, full scale mock-up and fatigue test and then flight test. These are the aerospace design should be involved in our aircraft. So top level requirement for civil aircraft. The aircraft manufacturers make a very careful analysis of the potential customer route structure, image and operating philosophies to determine that the customer's need and postulates a future operating environment. The manufacturer then designs an aircraft that provides an optimum balanced response to the integrated set of needs. Safety is always the highest priority and need to operate in a close second. So whenever going to design a aircraft, these are the top level requirements we have to focus in our aircraft. So requirements for military F9490. 5 operational states for the flight control system. Operational 1, normal operation, and operational state 2, restricted operation, and operational state 1, minimum safe operation, and operational state 1, controllable to an immediate emergency landing, and operational state level 1, controllable to an aircraft condition. So, probability of failure. So, what are the things will be failure in our aircraft? For example, if we are taking that bomber aircraft, heavy bomber transports and cargo and tankers, probability of failure per flight hours should be less than or equal to 5 into 10 power minus 7 percentage should be failure per flight hour. For rotary aircraft, examples like helicopters, that should be less than or equal to 25 into 10 power minus 7 percentage should be failure. All other aircrafts less than or equal to 100 into 10 power minus 7 percentage.